Imagine your users cannot access your Linux application. The firewall looks fine, SSH is running, the server is online, but the application is still unreachable. Before restarting services or changing configurations, let's see what the packets are telling us. Today, I show you how I use TCPDump in real Linux environment. First, let's update our package list. Now let's install TCPDump. The -y option automatically confirms the installation process. This command simply shows us the installed version of TCPDump. TCPDump supports dozens of options and filters. Don't worry, you do not need to memorize all of them. In this tutorial, we focus only on the options that system administrators use most often during network troubleshooting. Let's identify our server's network interface and IP address. The -d option displays all available network interfaces that TCPDump can monitor. In my case, I'll be monitoring the NAS33 interface through this tutorial. Now we're listening only for icmp traffic. icmp is the protocol used by the ping command. At this point, TCPDump is waiting for packets. I'm now sending ping requests from server 2 to server 1. Let's understand what we're looking at. The first IP address is the device that sent the packet. The symbol shows the direction of the packet. The second IP address is the device that received the packet. icmp echo request simply means that server 2 is asking whether server 1 is reachable. Now, let's look at the second line. icmp echo reply means that server 1 successfully received the packet and sent a response back. If you can see both the request and the reply packets, your network communication is working correctly. In production environments, this is usually the first thing I check. If users tell me that an application isn't responding, TCPDump immediately tells me whether packets are reaching the server or not. Packets never lie. Now let's make the output cleaner and easier to read. The NN option disables hostname and service name resolution. In production environments, I almost always use the -NN option. Without it, TCPDump might try to translate hostname and service names, which sometimes make troubleshooting more difficult. Notice that TCPDump is displaying the real IP address and packet information. This makes the output much easier to understand during troubleshooting. Imagine your Linux server communicates with hundreds of devices. Capturing every packet would quickly become overwhelming. Filters allow us to focus only on the traffic that we're interested in. Every packet shown here belongs to server 2. If you are troubleshooting a problem coming from a single machine, filters can save a lot of time. The -w option saves all captured packets into a PCAP file. What if the network issue happened 2 hours ago? Packet captures allow us to save the traffic and analyze it later. This is one of the most useful features of TCPDump when troubleshooting production servers. Let's verify that our packet capture file was created successfully. The -r option reads packets from an existing packet capture file. This allows us to analyze network traffic without generating new packets. It's extremely useful when troubleshooting intermittent network problems. Finally, let's analyze the packet captured file using Wireshark. I captured the packets on my Linux server using TCPDump and transferred the PCAP file to my Windows machine for analysis. This is the common practice when troubleshooting Linux server and production environments. I installed Wireshark on my Windows PC. I simply opened the captured PCAP file that we created earlier using TCPDump. To make our analysis easier, I filter only icmp packets. Here we can immediately identify the source IP address, the destination IP address, the protocol being used, and additional packet information. Wireshark breaks down every packet into multiple layers, allowing us to inspect every detail of the captured traffic. In our case, we can clearly see the icmp echo request sent from server 2 and this icmp echo reply sent by server 1. This confirms that both servers are communicating successfully. TCPDump captures the packets on the Linux server. Wireshark helps us analyze them visually on our Windows PC. Together, they are two of the most valuable tools every Linux system administrator should know.